Hello everybody, my name is Ron Heren. I'm a professor here at Maastricht University and the director of the Maastricht Multimodal Molecular Imaging Institute, and I have the pleasure to guide you around our laboratories today. M4I is a unique infrastructure here on the Maastricht University campus. What makes us unique is that we are able to look at the molecular complexity of many different surfaces. Being very close to the hospital, we actually work a lot on patient-based problems, which means we work on biopsies, on tissue sections, where we're trying to provide the clinicians with molecular profiles that help them precisely diagnose their patients. These molecular diagnostic profiles are the enablers of personalized medicine of the future. We do not only work on clinical samples, but we also work on material sciences. One of the applications that we work on here, for instance, is working on paintings, like this here. An old painting found on an attic, maybe worth something, it needs analysis. And that's what we do here. We actually prepare little cross-sections like this, actually tiny flakes of the painting where we stick a knife into it, chip out a small 1 millimeter piece of paint, and we can't handle those amounts of paint, so we embed them in these resins. And these resin blocks, we actually polish them so that all the individual layers of the painting become visible. The grounding layer, the colors, the varnishes. And when we look at those with our molecular microscopes, then we can assess whether it's a true 18th century painting or maybe a modern fake. Here at M4I, we use an enormously advanced infrastructure to make these molecular images. These molecular images constitute profiles of an individual, and one of my favorite profiles is the molecular profile of a hair. And a hair gives away your chemical secrets. It's like your molecular diary that shows you where you've been and what you've been exposed to. And with our high-end infrastructure, we can actually make these molecular images and visualize the distribution of molecules on surfaces. And that is actually what I'd like to show you in the guided tour today. So I want to invite you to join me, come to our labs and have a look at our mass spectrometry imaging infrastructure. Let's go. So, welcome here in the labs of M4I. And you are surrounded now by all different high-tech imaging mass spectrometry systems. Every single instrument you see here actually is a molecular microscope. So next to me here is our timsTOF Flex, and this is our latest and greatest high-resolution molecular imaging device, and that allows us to even more efficiently generate molecular images, where with very small pixels we can understand this molecular complexity. Whether it's a hair, a biopsy from the clinic, a piece of tissue, we can all put it in here and generate these gorgeous molecular images. So what makes us unique here at M4I is that we work with modern mass spectrometers, but sometimes they do not do what we wanted to do. So we need to do some engineering. And together with the instrument manufacturers and our engineering department here, we actually build new sources. One of the things that we are very good at is imaging. So they often ask us help to modify their instruments, or sometimes we have ideas how to improve the performance of modern mass spectrometers. So for instance here, a new multi-source that helps us to do even more accurate high-resolution molecular imaging with high-resolution mass spectrometry, really allowing us to unravel more spatial detail of our patients' biopsies. So that's how we use the infrastructure of the Maastricht Health Campus to break boundaries and take knowledge to cross those boundaries and do unique science that has never been done before, nor here on campus, nor anywhere else in the world. So, now you've seen our clinical lab here. Now I want to take you downstairs to our engineering lab. And there we'll show you the most high-tech imaging mass spectrometer you can see here on campus. Let's go. So here we are at the highest resolution mass microscope on the Brightlands Maastricht Health Campus. In this instrument, we use 3 particle accelerators to focus ions down on a spot of 50 nanometers. There they cause an explosion and they allow ions to fly through that drum onto this detector right here. With this mass analyzer, we are able to look at the chemical composition at the square nanometer. But This is an engineering lab, so we built something unique into this. And what is unique is this pipe that is sticking out, almost looking like a gun. This is a piece of engineering that we've patented, worked together with a company to build, and now allows us to do structural analysis of molecules in this high-resolution mass microscope. What happens is that ions fly through this drum, and right here they collide, they fall apart, and the fragments are injected into this tube. There they're structurally analyzed and give us the chemical structure on the 15 nanometer spot that happens right there on the surface of a cell, a piece of tissue. Really unraveling the chemical complexity of surfaces at the cellular level. So, in the beginning of this guided tour, I was telling you guys about the work we're doing on paint cross-section analysis. Well, this actually happens here at this high-resolution ion microscope. When these paint cross-sections are embedded, the resin is hardened, they're polished, and we can see under the microscope every layer. We actually put it here, mount it into this dome. We focus these ion beams down to the paint cross-section, scan every little nanometer on the surface, and understand the chemical complexity of the binding medium, the pigment particles, into great elemental and molecular detail. And that information helps us to understand whether or not the pigments that are in these paint cross-sections are real to the era where the painting is supposedly painted. So it helps us to understand the molecular aspects of aging of this complex work of painted art. So I want to show you guys something special. One of the things that we do here, as I said, is engineering, whether it's laser physics or mass spectrometry, or here at the back end of the mass spectrometer there's a detector. And this is actually a very special detector because this is a detector that we've taken from CERN, came here where we use it to look at our biomolecules. So really, as I like to say, from CERN to the surgeon. And that is what is uniquely possible here at the Brightlands Maastricht Health Campus, because we bring together engineering, biomedicine, physics, chemistry, all to really cross the boundaries of our knowledge, because we really have knowledge crossing boundaries on the campus here. Okay, you guys, I hope you've enjoyed this virtual tour through the laboratories of M4I right here at Maastricht University. A unique facility that I'm hoping to greet you once very soon live here on the premises, whether it's as a student, as a collaborator, or maybe as a fellow scientist that wants to help us improve our instrumentation through your engineering capabilities. Hoping to see you all soon. Now I'm going to sign off, say bye, and I'm going to go back to my research. Take care.